Our company, Gradical, helps medtech companies to choose the right plastic for their application, and that from a cost, technical, material compliance, and sustainability perspective. So what we help companies establish is a structured material selection process that takes into account all the requirements, including environmental side. And today, what we are going to talk about is we're going to start with the sustainability trend in medtech, and this is the reason why we're all here. I'm trying to convince you that this is actually an actual trend. Then we are going to talk about the use of recycled plastics in medtech. What are the pros, the cons, what are the challenges, and what has already been done. And then we are going to give you a small overview over the recycled plastics, because recycling plastics isn't equal recycling plastics. And then what we are also going to talk about, because this is like the second or the other face of the coin, so to say, is recycling of plastics from medical waste or from healthcare waste. And we're going to share some insights on what is being done and what can be done there and where the challenges are. Good. Let's start with the word sustainability, because I think the word sustainability has a little been bastardized. It has been in the recent years used as an synonym of ecology. So mostly when we talk about sustainable plastics or sustainable healthcare, what we actually mean is ecology. So we mean more ecological. And of course, this is the front where we're not doing so great right now. However, real sustainability includes ecology, it includes economy, and it also needs to include the social aspects. And if you want to translate that into healthcare or into medtech, this means stuff has to be good for the planet. The medical device has to be good for our pockets because we want to make a profit. We want to invest it in further developments. And then in the end, it also has to be good and in my opinion, also better for the patient. Because only if we have all three pillars, then we can make a really successful medical device. And if you get all pillars right, you will gain a strategic advantage with your medical devices. So that is really my key message, my key paradigm for thinking about sustainability, because a lot of sustainability is and talk about sustainability is just about making things greener without regard to patient safety and without regard to profitability, because those two pillars are super important and they cannot be sacrificed. Good. Then, is there a sustainability trend in medtech? And from a first principle, what you can do as an experiment, you can take the 100 biggest medtech companies in the world, and then you go through that list and check the Science-Based Target Initiative, which is a voluntary CO2 saving initiative, very plainly put. And what you find is that there are, I think the current status is 45 medtech companies in the biggest 100 in there. And if you take the accumulative turnover of these companies, you get something like 340 billion US dollars in turnover, which is, depending on which market estimates you believe, around 60% of the medtech market, meaning that the majority of the medtech market already is committed to CO2 savings. And what is very important in the Science-Based Target Initiative, this also means that they will go on and try to reduce their scope 3. So all suppliers of these companies, they will be under pressure to reduce their CO2 footprint. So yes, there is a sustainability trend in medtech, and there's also other indicators that there is a sustainability trend in medtech. For example, we have a bunch of new medical devices that are using sustainable plastics. Here we have a anesthesia and ventilation circuit that we helped co-develop with a consumable manufacturer from Taiwan. Then here we have a example that we're going to see later. This is an otoscope tip. We have lab consumables. We have also endoscopes, we have auto injectors, we have surgical devices. Those are the areas where sustainability is pushed hardest, because that is also where these devices are most associated with waste. Because, and maybe I'll bring up that point later, but if you talk to hospitals, they don't think about sustainability in a CO2 perspective. For a hospital, sustainability means waste. And what all these devices have in common is they're generating waste. If they're from a CO2 perspective better or worse than multi-use, that is another discussion. However, hospitals associate waste with sustainability, and there the companies are most under pressure to do something. And then there's also a bunch of recycling and take back program initiatives. So we have, for example, Johnson & Johnson and Ambu and Boston Scientific. They as manufacturers have initiated some take back and recycling programs where they're taking their used single-use surgical devices back and they're recycling them. Then there's also a bunch of initiatives that are, let's say, overarching in industry, like Remit or Recipen. There's also Vinyl Plus for PVC recycling and the Healthcare Plastic Recycling Council. And those initiatives show that there is certainly the need and the will of healthcare to do something about recycling. Is just not that easy, let's say. And I'm going to elaborate on where the challenges are. So we have these two fields. So we have on the left-hand side, we have the use of recycling plastics in medtech. So I'm taking a recycled plastics and I am going to manufacture a medical device from that under my name. So that is what we're talking about here. Can I do that? Am I allowed to do that? What are the challenges? The biggest challenge, of course, is the quality and risk management. It all depends also on the risk class. And in this case, we are doing something that is usually an upcycling. So if I take a recycled refrigerator and I make a single-use medical device out of it, that's clearly something that I would call upcycling. And uh, just a very, very small self-advertisement here, eco-design and sustainable plastic selection. That is basically what we do. So this is our service offering. So we are very much on the left-hand side, how to help medtech companies to establish these sustainable plastics in their medical devices. But then there's also the other side of the coin, as I said, recycling of plastics used in medtech. So basically recycling of medical waste. There we have a bunch of other problems. So we have the regulations. They are usually national, sometimes even subnational, as in Germany. Then we have the logistics. Usually contaminated waste cannot be transported by any company, or not by all companies. You need special permits usually. And then, so the big problem that we have is contamination. So if you imagine a stapler has been inside of a human body, there are all kinds of bodily fluids in there. So that is basically the problem that we're facing. How do we get this sterile and clean? And usually we're talking about downcycling here. The big, let's say, advantage in getting the foot into the door for the hospitals or into the hospitals is waste is a big cost driver for hospitals. So the contaminated waste is usually very expensive to get rid of. Usually it's incinerated. And then with that, that is a huge, not only environmental challenge, but it's also a cost point. And if you can save cost and environmental footprint, that's usually where there's a good business case doing so. Good, moving on. So if we're talking about the left-hand side, we want to use recycling plastics in our medical device. What speaks for this? Why would you even be so crazy to do that? So as we already elaborated, MedTech wants to reduce CO2. And that is not only because we do it voluntarily, but at some point the EU will force us to do so. And every company will start to reduce their CO2 footprint, also MedTech. We're not going to get an exemption. And then the second point is recycling plastics, especially mechanical recycling, has a fraction of the CO2 footprint of virgin. That's why you want to do it. It saves CO2 footprint, not because we like magically want to, let's say, just reuse plastics for whatever reason, but because it saves CO2 footprint. Then the recycling technologies in the last several years have improved massively. So 10 years ago, I would probably be booed off stage and never be invited if I'm talking about such a topic. And it was the prejudice against recycled plastics. Yeah, you can make flower pots and you can make park benches out of recycled plastics. But what I've seen from the last, I'd say, 10 years, the improvement has been massive. You can get transparent plastics. They don't smell anymore. They're very good quality. And this improvement will also, thanks to investments and thanks to political pressure, increase, or this trend will hold on into the future. So we're getting higher quality recycling plastics. And now I wouldn't be honest if I wouldn't speak about like what speaks against it. So it is true that recycling plastics have been seen in better quality, but there is always a trade-off between quality and the environmental impact. If you want high quality recycled plastics, they usually come with a worse environmental footprint, especially if we think about other recycling methods such as chemical recycling. Then the quality and risk management is just, it's not that it's forbidden. We will come to that point just now. But it's just difficult to do. So how do we make sure that the recycled plastic is always the same quality, that we will come through biocompatibility? If we're thinking about using a medical grade, always comes with the change control. How the hell do you do change control for something that has a variable input? So that is basically the challenge in using recycled plastics, especially mechanical recycling. Then the regulatory requirements, this goes a little together with the quality and risk management because the regulatory requirements are about quality and risk management. And the question I get asked so much is, am I even allowed to use recycled plastics in medtech? Because like this is a paradigm that just exists in medtech. It's like it's not possible to use recycled plastic. And if we go look into the MDR only knows the word material, and there's no plastic, there's no metal, there's no composite, there's no ceramic, there's just the word material. And there's no separate requirements for recycled materials or recycled plastics. So that means, by inference, that recycling plastics need to be as safe as virgin plastics. And the question is, can you do that? So there is no regulatory hurdle to using recycled plastics. It's just a technical hurdle. It's just very difficult to pull off. And I always use this example of medtech is between crutches and an implant. And if you look at it like that, both have a let's say medical purpose. They have an intended use, but the risk case is so much different. So I'm never telling you use a recycled plastic for implant. Nobody tells you that because it's like 5 companies in the world. I'm a little exaggerating, but it's like a handful of companies actually advertise their material, their plastics to be implantable. And if only, and this is virgin, if only a handful of virgin dares to sell their material into implants, then it is utopic to think that we are going to do it with recycled plastics. On the other hand, the crutch, the biggest risk of having crutches or having crutches made of recycled materials is the crutch breaks and the patient breaks the leg again. That's the biggest risk. And you can ensure the mechanical stability of a mechanical recycled plastic. So it's no problem to do a crutch, but it's impossible to do an implant. And at some point in between, there is a boundary where you wouldn't be able to use a recycled plastic. And I drew several boundaries because it also depends on the quality of your recycling plastic. And we're going to give you a small, very, very brief overview over recycling and recycling technologies. So there are a bunch of recycling technologies. You don't need to know everything, but the only thing I want to take away from this slide is recycling is usually equated to the following thing: mechanical recycling. So you take your PET bottle, you bring it to the recycling, it gets shredded down, it gets made into pellets, and then it's going to go into another bottle again. That is mechanical recycling. You shred it, you put it through an extruder or through an injection molding machine again, and then you have another plastic part. That is what is called recycling in, let's say, common language. However, there are a bunch of other methods, such as dissolution. So you take a solvent, I also call that solvent-based recycling. Take a solvent, dissolve the plastic, get rid of all the impurities, and then get the polymer back. And then you also have a bunch of what we would call chemical recycling methods, and this is actually the biggest part. So you can either just burn the plastic and capture the CO2, which is incineration and CO2 CO2 utilization, or you could use something like an enzyme or a solvent to get the monomer back. And they also have a very huge, let's say, space of environmental impact and yield and quality. So it's a very, very diverse field. I'm going to simplify in the next slide a little. And what we're going to talk about is the trade-off between quality and environmental impact. So we have chemical recycling, we have dissolution recycling, and we have mechanical recycling. And here we have to a little differentiate between post-consumer recycled materials, so something like household waste, and then post-industrial recycled materials. So if you in your production have some scraps and you sell that to a recycler, that will be a post-industrial PIR mechanical recycling. And if you have mechanical, or let's say, let's start with the chemical recycling. With the chemical recycling, what we see is that the quality is where we would want it for a medical device. It's virgin quality, basically. And if you want to, that the only thing that you would want from a chemical recycling is that it has a lower environmental impact, because the environmental impact, you use a lot of energy for a lot of these chemical recycling methods. As I said above, it's a very diverse field. I'm a little oversimplifying here, but what you would want is a lower environmental footprint. So this is the trend with, let's say, the arrows. Then with dissolution recycling, you are quite a good quality, not perfectly virgin. You have some issues with molar mass distribution and all that stuff. But for, let's say, intermediate risk medical devices, it's probably good enough. Also for something like a packaging of a medical device, it's probably good enough. And what you would want here is a little improve in quality, because these methods are not quite scaled as much as they could be. And you could also improve their environmental footprint. With mechanical recycling, you see a little bit the opposite. So mechanical recycling has a very broad quality and environmental impact space, I would say. And that depends a lot on how much the waste is actually, how dirty the waste is actually, and how much you have to clean the waste. So what we see in mechanical recycling is that you put in more energy, you put in more effort in order to get higher quality materials. And that is what I mentioned in the beginning. It's like we are seeing that playing out, that we get higher and higher quality mechanical recycling materials by implementing more sorting, more analytics, better washing technology, so that we can get higher quality mechanical recycled materials. So now, how would I actually go about doing this? This is a very brief instruction on how we would be doing this. If I want to use mechanical recycling in my medical device, I would be talking about a low-class medical device with a very short patient contact, nothing that is like long-term or implantable. And the first pillar is supplier management. So you need the quality agreement with the supplier. I just dropping in a small anecdote here. We went to a recycler once and we evaluated them for maybe can we use their material or not. And we were like, okay, we need to recycle polypropylene. Yeah, we have polypropylene. We are 99% pure. Cool. And then we asked, okay, we want a technical data sheet, a safety data sheet. We need a specification. We need Reach and Ross declarations. And they looked at us with like eyes big like this, and we're like, we don't know. It's polypropylene. We don't know more. And that was like the end of the discussion. If your recycler cannot do that, then it's the wrong partner to do so. So select your supplier according to your quality needs. It's like, and that is not like trashing recyclers because they come from a waste management perspective. They recycle cars or they recycle electronic devices. They're not a plastic company. And there you need someone with an expertise in supplying plastics. What are we actually looking for? So specifications, audit, limiting of waste source. So usually that is also a good idea. Can we limit the waste source? So for example, only recycled fridges or similar, or only recycled food containers, for example. And that is the first pillar that you need to dial in, supplier management. Secondly, quality and risk management. You need to have an incoming goods inspection, usually with a biocom. So what you would do is like you order bigger quantities, you order half a years of quantity with one lot, and then you check that lot for biocompatibility. So you run an extractable leachable study, and you run a cytotox. And if that comes out good, like you argue in your risk management that it's as good as it was last time when we validated it. So therefore, we need to lot by lot test. We also need to make sure that the variability in the MFI, so the flowability of the material, is under control, and for that we need in-process control, that we don't get flashes or anything like that. And then outgoing goods inspection, if we're thinking about the crutches, we might want to test some of them against mechanical strength so that we make sure that the patient doesn't break his legs. Good. And then the last thing, and I think this is the most important one, is you need to have a good stakeholder management. So this is nothing that you do as a U-boat project. You will have to engage your management. They have to have a buy-in, and you'll have to manage expectations. It's not going to be like first time right. It's like you'll have to have a certain learning curve. And you need to ensure communication with the supplier, with your management, and really manage these expectations, that they don't think it's just gonna work like any other plastic. There's gonna be some hiccups. Good. So I'm gonna show you an application, and then we're going to move on to medical waste. So this is an otoscope tip medical device that is MDR class 1 single use and has direct patient contact for a few seconds. And it is used, as I said, they use recycled polystyrol from fridges, and just the material, not the whole device. The material uses 75% less CO2 by switching the material. So if you're looking at recycled polystyrol versus normal polystyrol, is 75% CO2 saving. The whole device, I haven't seen an LPA, but there's significant savings if you can implement that. And I talked to them and they said, I have no, they're class 1. So they don't have to show this to a notified body, but I talked to the guy and he said, I have no issues with showing this to a notified body. I'm very confident that we're getting through this. So this is the proof that it's actually possible to use mechanical recycling in medical devices. And as a conclusion, yeah, it is possible. The use, however, is in its infancy, and we have a lot of hurdles. The biggest potential lies in simple medical devices with low risk and low patient contact, and we still don't know where the actual limits are. So that would be the key takeaways. Good. As always, if you have questions, just type them in the chat. I'll still have I think we will have to finish up at 1:30, so I'm going to go to the waste problem, and then we're going to have a 5 to 10 minutes discussion. Good. As I said in the beginning, hospital waste is seen as the primary sustainability challenge for hospitals. So they don't care about the CO2, they care about waste. Because like I did a project in Switzerland, and there we have a waste cost of around 800 to 1,000 euros a ton. And I spoke to people dealing with medical waste in the US, and translated as like I get the numbers in cents per pounds or US dollars per pounds, but if you translate that, it's going to be 750 to 1,900 euros per ton. So it's a significant cost for the hospital, and for healthcare professionals. If you talk to them, it's like sustainability is equal waste reduction. And let's talk about what the challenges are. So, number one, it is possible to recycle hospital waste. It's like what you usually hear, it has to be incinerated. That is not true. If you have the waste code contaminated waste, I'll not recite the exact waste code here. What you need to do is you need to change the waste code, otherwise it has to be incinerated. That is a very technical but very important detail. Meaning, if you sterilize your waste, which is usually done by steam sterilization, then you can recycle it. So you need to decontaminate or inactivate the waste using something like a steam sterilization. And what you then can do is you can recover a bunch of valuable materials. If you think about like catheters or something like that, they have iridium in there, and that is a very rare metal, or you have platinum, or you have gold in there. So it's actually, for the metal, it's actually financially very, very lucrative to recycle this medical waste. And the main challenges, as said, are the regulations, the logistics, and the decontamination. Then, coming back to why take-back programs are a very good start, but they will not solve the problem. I coined this term called the 27 bin problem. We have Ambu, we have Johnson & Johnson, also Boston Scientific. They have their take-back systems. And what they do is like they have a bin in front of the OR, and then the healthcare professionals throw the Johnson & Johnson, Ambu, Boston Scientific devices in that specific bin. However, if you have ever been in front of an OR, you don't have space for all your suppliers. So if all your 27 suppliers want to have a take-back system, you just simply do not have the space. So that is what I call the 27 bin problem. As it makes it very, very, let's say, visual what the problem is. It's just logistically not possible to have every supplier take back their system. So we need to switch over to something like an industry-wide or at least national collection system for taking back medical devices in order to recycle them. Because it's actually quite a challenge. We want to train staff, we have space restriction, the whole reverse logistics do not exist. There are a bunch of companies who have a monopoly on contaminated waste transportation, so special transport. And that is where a lot of the cost is going, because it's extremely expensive to hire those companies. Good. Other challenges include that it's extremely expensive to sterilize these components, and it's not a very, let's say, dense waste. So if you have plastic waste, if you ever collect the plastic waste, it's actually a lot of air and not a lot of plastic. So it's very light. And to transport basically air is not very, let's say, lucrative. So that is one challenge. And the second challenge is also usually designed for recycling isn't implemented. So we'll have to start from the design part, and we'll have to start from the collection system and contamination part. And then we will meet in the middle. And at some point in the next 15 years, we're going to have solved the problem. Good. In order to have some discussion left, I'm gonna be faster here. There are some, let's say, solutions to on-site waste treatments. The Sterilis solution and EcoSteril, which I have no association with, by the way. They sell machines that are basically big shredders that you can put your hospital waste in. It shreds it, it sterilizes it, and then at the end, it's normal waste that can be recycled, or it can be incinerated and transported with a lower volume. So that's a huge cost reduction. They have a good business case. I have 2 videos that you can be looking at. The links are here. And yeah, in the end, I just want to thank you for listening. Here are my contact details. I have a YouTube and a Spotify podcast where I deal with all these topics. So check that out. And yeah, now I would be open to questions.
Great, thanks, Lucas. We have it scheduled until 9:45 as well, so we do have some time, which is great for discussion. But thanks for that really insightful and very interesting presentation as well. So I will open it up for some questions now to the group.